Okay, we have looked at sequences that turned out to be quadratic. And we said that quadratic sequences have a constant second difference. That's how you recognize them. The other thing we said was that the standard form for the equation looks like this. What I asked you to do for homework was to actually go on Desmos and plot a couple of things and see what it looked like. So for example, I asked you to plot x plus 1 squared. And that's what it looked like. And then I asked you to plot x plus 2 squared. What did you find when you plotted x plus 2 squared? Did it go higher? No. It moved over. So if we look more closely at this, x plus 1 squared had its vertex here. X plus 2 squared has its vertex here. What would happen if I made it minus 1? Go up? Neither. Move to the right. Does anybody have any idea what it is you can do to make it move up? If I go outside of where the x is, and I add 1, it goes up by 1. And if I say minus 2, where does it go? Down 2. So if you notice, in this form, it's this number right here that makes it go left and right. If I make that minus 1, it goes to the left. So this is a particular form for writing the equation. It's another form of the equation. If I do this, then whatever number I put into h and whatever number I put into k are the numbers that are going to determine where the vertex is. So if I want the vertex to be 3, 4, then what I have to do is put 3 in here and 4 in here, plus 4. Well, if this number is negative, then it moves down. And if this number is over here, well, the form is this. So it's an x minus something. Whether this number is positive or negative determines whether it moves left or right. So if you have x plus 1, that's actually really x minus negative 1. So this would make the vertex move 1 to the left. So there are two forms of this equation. There are others as well, but two different forms. And this one focuses on the vertex. So what I asked you to do when you were working with Desmos was to see if you could figure out how you could control the parabola, how you could control the position and the shape. Let's take a look at what happens to the shape of it. Right. You'll notice that parabolas are these U-shaped things, but you'll also notice that if I put a negative sign before this, it flips the parabola upside down. Yeah, if I put a negative sign here, it flips it upside down. If I put a 2, it made it narrower. The bigger this number is, let's put a 21, the narrower it gets. If I put in a number that's less than 1, like 0.5, it gets wider. If I put in an even smaller number, say 0.4, it gets wider still. So it's this number here that controls the width. It's positive or negative that controls whether it points up or down. This number controls left or right. And this number controls moving it up and down. That's how you control them. Let's just look at y equals x squared. This is called the parent function. With any parabola, there's a point at which the graph changes direction. All the way to here from the left, it's going down. And the minute you get past here, it's going back up. The point where it changes direction is called the vertex. And by the way, just so that you know, the plural of this is vertices. If a parabola is pointing down, then its vertex is a maximum. because it's as high as it gets. If the parabola is pointing up, the vertex is a minimum. But in both cases, it's a vertex. This shape is symmetric. In other words, if I were to take this and fold it along this line straight down here, these two things would line up perfectly. So that's another characteristic of a parabola. Parabolas are symmetric, and the vertical line that goes through the vertex is called the axis of symmetry. That's what that's called. This line right here that goes through the center is called the axis of symmetry. Even if I move the parabola, you'll notice that the y-axis isn't the axis of symmetry anymore. The axis of symmetry has moved to the left along with the vertex. In each of these problems, you're being asked to identify the vertex and tell whether it's a minimum or a maximum. So the vertex here is right here at this point where it changes direction, and that means the vertex is 3, 1. Right? 1, 2, 3, 1. Okay, you guys remember that, right? Sure. First you do the x-axis and count 1, 2, 3, and then you figure out how high it is. It's 1. So this is the x value, and this is the y value. And in this particular case, this y value is the lowest y value that this function has. It starts way up here and comes all the way down here and gets smaller and smaller and smaller. When it hits 1, it turns around and goes back up again. It never gets smaller than 1. So that point represents a minimum value. And this right here is the line of symmetry, because it's the vertical line that goes through the vertex. And the equation for that line is x equals 3. Because everywhere on this line, x is 3. X is 3 here, x is 3 here, y is 1, but x doesn't change. X is 3 here and here. X is 3, y is 4, but x is still 3, up and down this line. For this one's going up to here, and then turns around and comes back down. So this point is a maximum value. It's -1. So the maximum value is -1. And the vertex itself is 1, 2, 3, 1. So it's -3, -1. And the line of symmetry comes straight through here, and it is x equals -3. So you'll notice if you know where the axis of symmetry is, you know the x value for the vertex, and vice versa. If you know the x value of the vertex, you know where the axis of symmetry is. This is called a quadratic function. The graph is a parabola. And if you don't know anything else, here is how you go about finding the graph. You put the equation here, and you start picking some values. 0 is the easiest one. Pick 0, plug it in for x, and figure out what will y be. Well, y is equal to 1/2 times 0 squared. Well, that's going to go away. You're left with -4. So it's 0, comma, -4. And that point is right here. So you plot the point. Okay. On this particular one, it happens to be the vertex. It isn't always, but it could be. Then you can plot another one. You could have plotted 1 or 2. Put in a 2 here. It's 2 squared. 1/2 of 2 squared is 2. Minus 4 is -2. So 2, comma, -2. Okay. 1, 2, 1, 2. That's also on the graph. If you put in -2, well, when it gets squared, it becomes a +4. 1/2 of 4 is 2. And again, we have 2 minus 4 is -2. And you'll notice here, right, -2, -2, you'll notice that these two are mirror points. They're on the same y value, so they are equally distant from the axis of symmetry. If I know I have a point here, and I know that this is the axis of symmetry, I can count 1, 2 over here, and then count again 1, 2, and know that there's a point there.
So
Yep.
is it always going to be like symmetrical? Or?
It will always be symmetrical. A parabola is always symmetrical.
So
It won't always be centered on the y-axis, but it will always be symmetrical. And if you can figure out what the axis of symmetry is, you will always know that if I go over here and this point is exactly this distance from the axis of symmetry, I can go the other distance, the other direction, the same distance, and put another point there. So that's how you go about graphing one of these. By the way, you'll notice with this particular table of values here, if we just looked at the y values, this is -6, this is -2, this is +2, difference here is +6. From 4 to -2 it's -6, from -2 to -4 is -2, from -4 to -2, that's going back the other way, it's a +2, -2 to 4, that's +6. Let's look at the second differences. 4, 4, 4. Okay, so if I were making a table of values here, let's say this is my x. Let's do -2, -1, 0, 1, and 2. Okay? So if I put in -2 here, it's minus -2 squared plus 5. -2 squared is 4, so this will be -4 plus 5, and that's equal to 1.
Wouldn't it be +4?
It would be +4, but then it's negative.
Oh, because the negative's outside.
Right, exactly. Okay. So the thing to remember about this, -2 squared is equal to -4, and -2 squared like that is equal to +4. The reason for it is the order of operations. Taking the negative of a number, like this, is multiplying the number by -1. Squaring it is an exponent, and exponents come first in the order of operations. So you have to square this first, and then apply the negative. Here, the thing you're squaring is everything inside the parentheses. So the number is already negative, and you're squaring it. So this becomes -2 times -2, where this is equal to, let's do it this way, this is equal to -2 times 2. So now, if I put in -1, -1 squared will be +1, and then I make it negative, plus 5, that's going to be 4. If I put in 0 here, that's going to be 0 plus 5, that's 5. If I put in positive 1, that's going to be turned into a negative 1 and 5, so that's 4 again. And now, what do I know about this point?
1.
So what does that look like? Well, if you're doing a rough graph, you say, well, okay, negative 2, positive 1 goes here. Negative 1, positive 4, 1, 2, 3, 4, goes here. 0, comma 5, that's going to go up here. 1, comma 4 goes here. And 2, comma 1 goes here. What do you notice about this? It is a parabola. This number is as high as it goes, so it'll be a maximum. And it is the vertex, so the vertex is 0, comma 5. And this is what it looks like if you're trying to do it perfectly. What's the axis of symmetry here? Axis of symmetry, you've got to give an equation. X is equal to 0, yes. Okay, so this would be x is equal to 0. That's what this line is. That's the axis of symmetry. Let's look at this one. And let's do the same kind of thing for a table of values here. Let's have x be negative 2, negative 1, 0, 1, and 2. If I put negative 2 in here, I square it, I get 4. 4 minus 4 is 0. If I put negative 1 in here and square it, I get 1. 1 minus 4 is negative 3. If I put 0 in here and square it, I get 0. So now I have negative 4. If I put 1 in here and square it, I get 1. 1 minus 4 is negative 3, and we have turned around and we are going the other direction. And if I go to plot those points, negative 2 comma 0 would be here. Negative 1 comma negative 3 would be here. 0 comma negative 4, that would be right here. And we've turned around now, so I've got negative 3 here and 0 here. This is a parabola, right? The vertex is 0 comma negative 4. It is a minimum value. And the axis of symmetry is x equals 0. Okay, this is what it looks like when it's done perfectly. Okay.